Okay, does anyone remember what a rational expression is or a rational number is? Has a word in it that helps explain what it is. Look at that word rational. And there's a word in there that may help me to know what kind of number. Jenna? Yeah, it's something to do with ratio. And does anyone remember what a ratio is? It's a comparison of two numbers. So a rational expression is simply a fraction. If you think of it as a fraction, you'll be okay. Even if it's not written in fraction form, it could be written in fraction form, and that's what we're dealing with in this chapter. Okay, here's the definition of rational expression. So we do need to get this down because this whole chapter is full of it, and if we don't get it, it makes it really hard. Okay, I don't know where that paper is. Rational expression is an algebraic algebraic fraction whose numerator and denominator are polynomials. All right, so get this note because this is a good basis of what we're doing. Okay, a rational expression is an algebraic fraction. So we have two types of fractions we've dealt with, numeric and algebraic. Does anyone know what the difference is? Numeric fraction, algebraic fraction. What do you think the difference could be? Jack, what do you think? Numeric has just numbers. Algebraic has letters and or numbers. So it has to have letters, and it can also have numbers as well. Whose numerator, which is what part of the fraction? You got to know which part the numerator is. Top, denominator, bottom. Wait, what chapter is this? This is chapter. That's polynomials, but this is chapter 12. Where did we learn about polynomials? Chapter 9. Wait, you're telling me that chapter 9 is inside of chapter 12? And the answer is yes. That's exactly what I'm telling you. And hopefully it makes it easier. By the way, chapter 10 is also in this chapter, hidden. Anyone else see this? Okay, I'm going to move on here. Write down a few of these expressions here. 6 minus x over x. Let's go with 5m plus 3 over m plus 6. And then we'll go with x squared minus 5 over x squared minus 5x plus 6. Okay. The first one here, 6 minus x over x, is a fraction. It's an algebraic fraction. Its numerator and denominator are polynomials. Therefore, this expression is a Oh, you guys are hurting me right now. My heart hurts right now because of the lack of enthusiasm. I'll help you out, though. It's a rational expression. Okay, Carson, the numerator is what type of expression is that? The numerator. It's a polynomial. Harrison, the denominator is also a polynomial. Nate, you have two polynomials, one over the other, numerator, denominator. That's as an expression called rational. Abby, what is this expression called? Rational expression. Jenna, what's the numerator? Sorry? Polynomial. Maggie, what's the bottom? Lily G, what kind of polynomial is this numerator? Binomial. Emery, what kind of polynomial is this guy? trinomial. You guys see where we're getting all this stuff from? Okay, there's something special about these fractions. Not only are they rational expressions, but they all have variables. Would you guys agree with that? Okay, in this first rational expression, x can be any number in the world. Any number you can select except for 1. Can't be this number. What number can x not be? It cannot be it. Yeah, Turner? What do you have against 0? Yeah. X cannot equal 0. Does anyone know why not? Like, why can x not be 0? Just look at that expression. It can be anything. Okay? Rosalind, help me out. Why can x not be 0? You know? 0 to 6 minus x? Wait, are you allowed to have a fraction with a denominator of 0? No, you are not. So that is correct. X cannot equal 0. Let's look at this one down here, or over here I should say. What can m not be? It can be anything in the world. It can even be 0. But m cannot equal, Jenna? M does not equal negative 6. Alex, why can m not be negative 6? It could be anything else. Yeah, what would the denominator be if I put negative 6 plus 6? It'd be 0, so that's not good. On the third rational expression, x can be many things except for 2 things. It cannot be these 2 things. Does anyone know what those 2 things are? 0? Nope. Negative 6? Nope, it could be that. Okay, let's look at this bottom right here. I'm going to give you the answer, and it's actually in your book if you needed to know. X cannot be 2 or 3. X cannot equal 2, and x cannot equal 3. Does anyone know why? Matt?
Because in the bottom, the denominator would equal 0.
Yeah, that's true. If you put in 2 in the denominator, for x, you're going to get 0. If you put in 3, you're going to get 0 in the denominator. But how do we even know that? How is it even possible? You just pick random numbers and hope they're not going to be? Can that bottom trinomial be factored? Can it be factored? Chapter 10. All right, everyone stand up. Stand up. Man, if I had water in a spray bottle. Swivl, watch out. Okay, go ahead and stretch. Whatever you need to do to stretch. If you just need to do that, stretch. If you need to do that, just do something. Get that blood flowing. If not, we can run laps, then come back, do the homework, and not get your test. So which one is it going to be? All right, stretch, and then once you're done stretching, you can sit down. Okay, this is a trinomial. This is from chapter 10. And I can factor it into 2 binomials. What's the number in front of x squared? 1. Which means automatically I can put x and x in that first spot. Does anyone know what those numbers are going to be? What are those 2 numbers that fit into there? Carrick?
Negative 6 and positive 1.
Negative 6 and positive 1.
Wait, no. Negative 2 and negative 3.
Negative 2 and negative 3. How many of you agree with that? Negative x minus 2, x minus 3. Okay, that's it. Because what's negative 2 times negative 3? Positive 6. What's negative 2 plus negative 3? Negative 5. Okay, does anyone see why x cannot be 2 and 3? Can anyone tell me why? I know Matt knows, Jenna knows, Jackson. Why can x not be 2 and 3?
Because if you do all the multiplication, subtracting will equal 0.
Yeah, if you make x equal 2, what happens here?
It becomes 0.
If you make x equal 3 over here, what is that going to give me at the end?
0.
Yeah, so x cannot be 2 or 3. It's excluded. Okay. These circled values, this guy, and that guy, are called, and this is something you need to know, excluded. I'll make this clear. That didn't help. Excluded values. Okay, in your homework, when they say, find the excluded values of this expression, you're like, what's excluded value? Well, it's just whatever that variable can't be. In this case, those are the values. Okay, example number 1. Autumn, can you read when you're ready? Example number 1, the problem. Just the bold type at the very top.
For each rational expression, state the values of the variable that must be excluded.
Okay, so example 1a, the value or the rational expression 7b over b plus 5. Okay, who can give it to me right away? What's the excluded value for b? Yep, b cannot equal -5. That's it. You're done. Easy enough? I hope so. Just look at it. B cannot be -5. If it is -5, that denominator is 0. We do not want that. B. Abby, can you read for me the rational expression in B?
R squared plus 32 over R squared plus 9R plus 8.
Okay, what can R not be? Well, looking at it, just the eye test, I don't know what R can be or not be unless I factor it out. So who can factor out R squared plus 9R plus 18? Brian? So R, you said plus?
It's 8.
Oh, 18. Gotcha. Thank you. Can you factor it out?
Sure.
I'll give you some time. So you're thinking 2 factors of 8 that add up to be 9. 4 and 2, no.
1 and 8.
1 and 8. Positive 1, positive 8. What's 1 times 8? 8. What's 1 plus 8? 9. So does that work? Okay. Harrison, can you give me one excluded value for R? Just one. R cannot be?
1, 8, -1.
Thank you, Rosalind. -1. And Lily Mooney, what can R also not be?
-8.
-8. So R cannot equal -1 or -8. It can be anything else but those two values. How many of you have a question on how to find excluded values? Are you good with the excluded values? Good. Because I want you to look at page 663, and you're going to find some excluded values. I want you to do number 6. I just want excluded values. Don't do the rest. They're asking for other things. I just want excluded values. Yes, ma'am? How do you get what? Say that a little bit louder. Do you get how you don't want this to equal 0? So what number would B have to be for this to equal 0? -5? Because what's -5? Are you looking up here? Yeah, what's -5 plus 5? So you don't want that. You don't want B to be -5. Okay. I'll go with Carson. What can A not be?
A cannot be 0.
A cannot be 0. Jack, what can Y not be?
0.
That's what he said. I said Y. Why can Y not be? What can Y not be?
0.
Okay. Did you guys get A and Y do not equal 0? Sorry, guys. You guys get that? A and Y cannot be 0. Good. Do number 8. What can those variables not be? I don't want them to be this. If they are, it doesn't work. So number 8. Okay. Alex, give me what A cannot be.
0.
Okay, she says 0. And Matt, what can M not be? 2. How many of you got M cannot equal 2 and A cannot equal 0? This is not tough, right? Good. Number 11. Okay, who feels they have these answers? These answers, plural. Good. Okay, what can M not be? Autumn. What's one value that M should not be? She says 3. So M does not equal 3. Comma. M can also not be, Claire? 9? If M were 9, it'd be 81 minus 9, and you can have that. It'd be 72. So M can equal 9. But M cannot equal this other number. Maggie? Negative 3. Who put that? Who put 3 and negative 3? What? Why? I get 3. 3 makes sense to me, but why negative 3? Yeah?
Negative 3 times negative 3 is positive 9.
Oh, yeah. What's negative 3 times negative 3? 9 minus 9. Oh, yeah. Can this be factored? Is it a difference of squares? Can you have factored this right here into m minus 3, m plus 3? Is that possible? So what can m not be now? 3 and negative 3. You guys see it? How many of you, so raise your hand high if you got it the first time. You're like, you got those. Boom. Raise your hand if you now understand why those two are. Okay. So be careful with that. And I would say factor if possible. So that sounds really fun. Did we factor recently? In fact, some of you did it on your own. You know that I looked up on IXL and I could see how much time, how many problems, how many you got correct, what your score was on factoring. Do you know I could find that out? And some of you, I was like, oh, wow. They practiced a lot, and guess what? Their test, they did very, very well. Very well. In fact, you can't get more well than that. Do you notice that? And some of you didn't do anything on IXL, and you still did well. Whew. You do this. And some of you still did okay. And some of you didn't do anything on IXL, and you didn't do as well as you could have. And that one, I'm like, oops. Can you do well? Can you do better with IXL? Possibly. Can you do well without IXL? Is that possible? Of course it is. But you'll see. I actually put notes on your paper that help you to know if you did well or not. Okay. You guys okay with this? Okay. Let's go to the last concept. It's very easy. I want to make these as simple as possible. Let's go to example number 2. Example number 2. I have a rational expression. But before that, do you guys see right above example number 2? Yes, sir?
What if there is no excluded value? Is that possible?
Yes, like if the number down low is just like a number 3, negative 5, there's no variable. The variable that would have been up top maybe, it could be anything. Yes, it's possible.
Also, if there's, so like, oh yeah, what if it was like m squared plus 9? What would your excluded value be?
Yeah, would there be any? Yeah, because you can't make m squared plus 9 equal 0. So yeah, can do it. No excluded values on those. So good, good. Okay, example number 2. Do you guys see right above example number 2? Do you guys see where it says remember that? Can you just look at that real quickly? Right after it says remember that. I want you to look at that string, and I want someone to explain it to me. And if you do, I might cut off some problems from your assignment. You may begin. I'll give you 1 minute to figure it out. Explain to me what in the world they're saying in that line right above example number 2. Oh, that got the page turning. Okay. Okay, I'm going to give you 1 more minute because I feel like I should give you at least another minute to try to explain it to your neighbor. What in the world it's saying. If they get it, that's a good sign. If they don't get it, go back to the drawing board. Go ahead. Explain to your neighbor what that line means above it. Okay, I'm going to give the class 2 chances to get it right. 1 try. If you didn't get it right perfectly, that's okay. I'll give you another chance. But the second time, please get it right for the sake of your classmates. First group right here, explain it to me. One of you, any one of you. Okay. I'm going to give another chance, second chance here. Oh, someone wants to take the chance. Are you sure about that? You want to take it? Sure. All right, go ahead.
You find the KCF, the top and the bottom, and then you do that times whatever like you do. If you had, for this example, it would be 9 squared y is u. So the common denominator would be 3x y z. And so on the top you would have 3x y z in parentheses times 3x, because you have whatever's left, and then you do that over 2x y z times a to z. But 2x y z over 2x y z cancels out, so it would be 3x over a z. And
You guys want to clap for that?
That was a lot.
That's a good motto to go by. Jen, I have one question, and then I'll be done. 3xyz, the example you gave me, over 3xyz equals what? That's what we want to get. Very good. Okay. All that means is this. If you have common factors in the numerator and denominator, you can cancel those out because what's any number over itself? 1. And you can take that out and keep it the same value. So let's look at example number 2.
What would happen if she got it wrong?
That would be bad.
Will we have to go away from break for...
No, of course not.
Well, we already have.
Just one day.
We already have.
Jenna, just be thankful. And you too, class, be thankful. Okay, listen carefully on this problem. It asks you to simplify and then state the excluded values of x, y, and z. Just do the excluded values real quick. And I'm going to ask you right now, Brian, x cannot be?
0.
Can't be 0. Lucy, y cannot be? Emery, z cannot be? Oh, how nice. Those are my excluded values. They are all part of my answer. It says state the excluded values. I did that. Okay, now to make this simpler. Oh, man. I was going over this with a student this morning. I was thinking to myself, this is awesome. because I'm telling you right now, there isn't just one way to do this problem. There are at least 3 ways to do it. I'm going to give you one way to do it, and if you figure out another way, let me know. Okay, what I want to do here is I'm just going to write out the prime factorization of both. And you're like, prime factorization? What's the prime factorization of 9? Good. Don't bog yourself down too much with that. Without exponents. And then what's the prime factorization of 24? If you don't know how to do it, just do your factor tree. Or sometimes you start memorizing these, but what did it be? Sorry? Oh, okay, great. This is, I would say, maybe the most extensive way of doing it. That means it's the longest way of doing it, but it's the one that's very easy to get correct. Are there any common factors within the numerator denominator? Yeah, how many of you agree that we have a 3 and a 3 in each? What's 3 over 3? 1. All right, any other common factors? X is 1 over 1. Anything else? Y over Y. Anything else? It doesn't matter which ones you cross out, by the way, as in the variables. Anything else? Okay. What's left? 1 times 3 times 1 times x times 1 times 1. 3x. You're left with 3x. What's 2 times 2 times 2 times 1 times 1 times 1 times z times 1? 8z. That's simplified.
Wait, is that your answer?
Is it simplified? So is there any other thing you can cancel out to get to that value? Or sorry, is there anything common between the numerator and denominator? Anything else common other than 1? No. So that's simplified.
Wait, so how we simplify is we just get the common stuff?
Yeah, you can either get the common factors out or get the GCF out in one swipe, which you can, but sometimes it's not super clear. Is there anything else that cancels out between the numerator and denominator? You have to ask that question before you move on. No, you're done. I got to do this because this is so important. Okay, the other way you could have done it was, what's 9 over 24? 3 over 8, right? You guys agree? 3 over 8? Okay, this is going back a few more chapters, and I hope you can get it better this time. Do you remember when you have common bases being divided? Do you guys remember that? What's x to the second over x to the first? X to the first. What about y over y? Yeah, it just becomes 1. What's z to the first over z to the second? Z to the negative first. But do you want negative exponents? So what do I do with that z to the negative first? Bring it down there. And so now I'm left with 3x over 8z. Oh, look at that. Same answer. I think I'm going to leave it there. I think the easiest way is prime factorization. So cool. Yes.
Isn't there another one with the GCF?
Go ahead.
Where
Yeah.
you take out the GCF?
Yeah, what's the GCF of, and let me cancel these out. Okay, I'll go with it because you brought it up. Go ahead. Carson, what's the GCF of these two expressions?
3x, y, and z.
Okay, so I'm going to do 9x squared. Is that a y? Is that a y? Is that my writing? Oh, it's because I crossed out the slash. Okay, the GCF is 3xyz. Would you guys agree with that? If I divide the numerator and the denominator by the same thing, what's 9 divided by 3? What's x squared divided by x? What's y divided by y? What's z divided by z? Do you guys see how I got that numerator? You can do the same thing with the denominator. You get the same answer. 3 ways. 3 ways. Is there only one way to do these problems? Don't insult me and say yes. Or don't insult yourselves because you know what those answers are. Example number 3, and I think I'll give you one more problem after that, we're done. Example number 3. A plus 3 over a squared plus 4. Okay. This is going to get a lot of us if we're not paying attention. I just want to simplify and then state the excluded values of A. Can you give me the excluded values of A first? And if so, how did you do it? Okay, Jack? Say that again. Oh, the excluded values? Okay. How'd you get that? Sorry? Okay. How many of you agree that this trinomial breaks down into these two binomials and the excluded values are correctly identified as -3 and -1? So excluded values out of the way. This is where you got to pay attention here. Okay. Can I make this any simpler? What can be simplified here? How? It's impossible. No, it's possible. Maggie, what do you think can make this simpler?
You can divide the numerator and denominator by a plus 3.
Okay, I'm going to divide this by a plus 3 and divide that by a plus 3. What does that become? 1 over 1.
So 1 over a plus 1.
What? 1 over a plus 1? You can't. Okay, ready guys? Please listen to the explanation because if you don't get it, it's going to be hard. Are these two, so this and this, are they being multiplied? Okay. This right here is all by itself, but can you guys see that a plus 3 and a plus 3 are common factors in the numerator and denominator? And you're like, how do you know that? Well, what's a plus 3 being multiplied by? 1. So can you cancel out common factors? Yes. And that extends to factors that are sums. That's my answer. That's it. Okay, let's do a couple of those because some of you are giving me that blank look. I get it. Look back to number 8. You know how you did the excluded values on 8? Now I want you to make it simple. So on number 8, on page, 663, number 8, you got a times m plus 3 over a times m minus 2. Okay. Are there any common factors? Notice the use of the word factor. What is it, Jackson? I agree with your A. These are common factors. So that's 1 over 1. You guys okay with that one? A over A, just 1. But here's where the problem arises. Are these common factors? That's a good question. Wait, Mr. A, isn't m plus 3 being multiplied by A? Yeah. Is m minus 2 being multiplied by A? Yep. So the A's cancel out, but why can't the M's cancel out? They can't do it. Claire? Is m being multiplied by 3? Is m being multiplied by -2? No, so these aren't common factors because they're not being multiplied. M is being added with 3, m is being subtracted with 2, or added with -2. So you're left with m plus 3 over m minus 2. Can't make that any simpler. That's it. Okay? Try out number 10. Simplify number 10. There. Yes, sir. So here's what's happening with m and 3. What's happening between m and -2? Yeah, so is m right now a factor? Is it being multiplied by, is m, so not common factors, you can't cancel them out. Here, what can get canceled on number 10, if anything? R minus S. Okay, let's see. This one and this one, is that okay? Oh, what else can I cancel out? Anything else? Oh, man. Okay, your answer is R plus S over R minus S. That's your answer. Okay, you can cancel out common factors. Can you cancel out common addends? Did we ever talk about common addends being cancel out? No. That's it. Yes, ma'am?
What are the excluded values for number 10?
Ooh. I know one of you knows the excluded values on number 10. Do you know?
Is it R cannot equal S?
R cannot equal S.
And S cannot equal
And I'll leave it like this. R cannot equal S. Whatever R is, it can't be S. It can't be the same thing. Because if R equals S, what's S minus S? 0S, which is what? 0. I don't want that. If S equals R, so if S equals R, what's R minus R? 0? You can't have that. Good. Yes?
Why did you cross out those two? Couldn't you just cross out the ones below?
Oh, yeah, you could have done that. It doesn't matter which ones. This one and that one, or these two. Okay, last one, and then I'll let you go. On number 11, I want you to make it simplified. Go ahead. And I'll write your homework up here. Get your test ready to pass out. Actually, can you check with your neighbors, see what they get after you get your answer? I think that will reveal that answer. You guys get the same thing? I hope it is the right thing. Yeah, you're supposed to get a fraction.
Oh, yeah.
Right?
Is the test going to be the fourth or the third?
Third. So it was the last grade of your last quarter. The previous quarter, I should say. Yes, ma'am? Okay. Yeah, she had a question. Go ahead.
I just don't understand how you.
Can you factor that out? Is it a difference of squares? Factor it out first, then you'll see it.
This is right.
Maybe. All right. Lily Mooney, what's the answer? Did you ask Lucy? No, sorry.
Yeah.
Oh. Go ahead.
So when you break it down, would it be n minus 3 times n minus 3 or n minus 3 times n plus 3?
The plus minus. One's going to be plus, one's going to be minus. M minus 3, M plus 3.
Then the answer would be 1 over n
1 over m
plus 3.
plus 3. How many of you got that? Okay, how many of your teammate helped you a little bit? They gave you a little boost? Okay. How many of you helped your teammate? Okay, there you go. Okay, homework's up there, and I hope you